Students, once again, now we will determine the density of the liquids, and as we know that the formula density equal to mass per unit volume. So for measuring the mass we require the beam balance again, but in the case of the liquid, to measure the volume of the liquid, we cannot use the formula as we did in the case of regular solids or irregular solids. So because they do not have the definite shape, so for that, for measuring the volume of the liquid, we will use the measuring cylinder. So look at that, this is a type of the measuring cylinder. This is it is made from the glass, and here there is some is the marking that is from 0 to any marking on the depend upon the capacity of the cylinder. So this is in the milliliter, and we know that 1 milliliter equal to centimeter cube. So we will perform a simple activity to measure the volume of the cylinder. So this is the activity number 4, to find the density of the given liquid, say milk. So what are the material required? A glass beaker, measuring cane or a measuring cylinder, beam balance and milk. So first take a clean and dry beaker. Determine the mass of an empty beaker. So पहले empty beaker का mass determine with the help of the beam balance. Say this is m1 gram, that is. Then take a measuring cane of a fixed capacity, say 100 milliliter. So this is the volume of the milk, and pour into cane up to 100 milliliter mark. Then carefully transfer the measured volume, that is V equal to 100 milliliter of the milk, into the beaker. Finally, we can determine the mass of the beaker and milk contained in the beaker. For example, it's m2 gram. So what we did, first we determine the mass of the empty beaker, say it is equal to m1 gram. Then we determine the mass of the beaker with the milk, that is equal to m2 gram. So what is the mass of the milk? We will subtract these terms, so that is m2 minus m1 gram. So this is the mass of the milk. And what is the volume of the milk? That is equal to the capacity of the cylinder, that is we have taken, that is 100 milliliter. So 1 ml equal to 1 centimeter, so it will be the 100 centimeter cube. So as we know that the formula of the density, that is equal to mass per unit volume. So value of the mass is m2 minus m1, and the quantity of the milk we have taken by volume, that is equal to 100 centimeters. So put here, then you will get your answer. So this is the simple technique to find the density of the liquid. Now we can also determine the density of the liquid with the help of the density bottle. So what is the density bottle? A density bottle is a specially designed glass bottle which is commonly used to determine the density of the liquid. So look at this diagram. This is the density bottle, a specially designed density bottle. So what is the density bottle? With the help of this density bottle we can find the density of the liquid also. In the previous activity we use the measuring cylinder, now we are going to use the density bottle. So इसका जो size रहता है, जो इसकी general capacity रहती है, that is from 25 milliliter to 50 milliliter. एक small sized glass bottle होती है with the glass topper. So look at that, this is the glass topper and it has a hole. Look at that. So it is a hole along their length. So how we can use to measure the density of the liquid? So when the density bottle is filled with the liquid and glass topper is inserted in the neck of the bottle, excess liquid rises through the hole and is drained out. So what is going on? First what you have to do, first remove this glass topper, then we will pour some liquid in this bottle up to its brim. Then after that put the glass topper, then what will be going on? Then the extra water, or you can say that the liquid, it will be risen up in this hole. So this is the extra liquid. Then we will remove it from this extra only in this glass topper, not all. Then after that we can calculate the density of the liquid. So let's perform an activity to find the density of the liquid with the help of the density bottle. So this is an activity 5, to determine the density of the liquid using a density bottle. So what are the material required? The density bottle, stopper, a liquid or any liquid, oil or glycerin or even milk, a tissue paper or a piece of dry cloth and a beam balance. We required again beam balance. So first Determine the volume of the density bottle which will be given. It may be 25 milliliter or 50 milliliter. It depends upon the capacity of the density bottle, because it is required into two shapes, that is 25 milliliter and 50 millimeter. Then after that we have to calculate the mass. So first use the beam balance and calculate the mass of the empty bottle, that is m1 gram. Then mass of the bottle with the liquid, whatever the liquid you put in this bottle, whatever it may be, oil, glycerin, milk, even water, whatever. So then measure the bottle mass of the bottle with the liquid, that is say m2 gram. Then again the mass of the liquid, what will the mass of the liquid, that will be equal to m2 minus m1 gram. So as you know that volume will be equal to 25 milliliter or it may be 50 milliliter. So we will put these values here and again we can calculate the density of the liquid. So what is the main point is that when you pour the liquid in this bottle, first remove this glass topper, then up to this brim, then after that put this glass topper in the bottle, then the extra water or liquid will rise up this in this hole. We will drain it with the help of the cotton cloths. Then this level will be here, so it will be the up to this level. This will be the volume of that particular liquid of which we are going to measure the density. So with this formula, this is a very simple method, we can determine the density of the liquid with the help of the density bottle. Now look at here, density liquid mass per unit volume m2 minus m1 over v gram per centimeter cube. Now look at this example number 9 on page number 33. So they are giving an empty beaker weighs 112 grams. So look at that, this is the empty beaker, it is not contained any liquid. When 100 milliliter of milk is poured into the beaker, so what is the amount of milk, that is 100 milliliter. The mass of the beaker changes 215 gram. So what is the mass of the empty beaker, that is 112 gram, that is say m1. Then after that mass of the beaker plus milk, that is equal to m2, that is equal to 215 gram. So mass of milk m equal to m2 minus m1 equal to 215 minus 112 equal to 103 gram. And the volume of milk they are giving, that is 100 milliliter. As we know that 1 milliliter equal to 1 centimeter cube, so 100 milliliter equal to 100 centimeter cube. And the formula density equal to mass per unit to volume. So mass 103 and volume is 100 divided it, then it will 1.03 gram per centimeter cube. And the next is an empty density bottle of capacity 50 milliliter weighs 27 grams. So look at that empty density bottle, this is empty, or its capacity is 50 milliliter, so volume is given, and its weight, empty bottle has weight, that is 27 gram. When completely filled with the glycerin, it weighs 92 grams, so its mass is increased from 27 to 92 gram. Calculate the density of the glycerin, express your answer in SI unit. So now look at that. The volume of the density bottle, they are giving 50 milliliter and 1 milliliter equal to centimeter cube, 1 centimeter cube, so 50 centimeter cube. The mass of the glycerin, now look at that, with glycerin 92 gram, without glycerin 27 gram. So 92 minus 27 gram equal to 65 gram. So density of the glycerin D equal to mass per unit volume. So put these two values 65 over 50, then you will get 1.3 gram per centimeter cube, and we have to convert gram per centimeter cube into kilogram per meter cube, and we know that 1 gram centimeter cube equal to 1000 kilogram per meter cube. So multiply both the terms, then you will get 1300 kilogram per meter cube. So this is the density of the glycerin. So as we know that density equal to mass per unit volume. Now the next topic is the relative density. Look at that, this word relative. So what is the meaning of the relative? So in order to have a comparative idea about the heaviness or lightness of the objects of materials, then we define a new term that is called relative density. So it is a comparison of the densities of the two objects or their materials. So from that you can get whether the given substance is heavier or lighter than that of the other material or objects. So it is the ratio of the density of the substance to the density of the pure water at 4 degree Celsius. So here we are going to compare the densities of the substance with the density of the pure water. This is our standard with which we compare the densities of the other substances, whether it is liquid or solids. But density of pure water at 4 degrees Celsius. So why it is 4 degrees Celsius? Because at 4 degrees Celsius water has maximum density. Yes, at 4 degrees Celsius water has a maximum density. So what is the formula for relative density? That is equal to density of a substance D divided by density of the water at 4 degrees Celsius, that is dW. So d over dW. So density has no unit. Why? Because we are dividing the same physical quantities. So here look at that, density over density. So both units will be cancelled out, then you will get no units. Getting? So density equal to mass per unit volume. Further, if you put the formula of the density, then the density equal to mass per unit volume. So mass of substance divided by volume. Similarly for the water, mass of water at 4 degrees Celsius divided by, now look at that, we are having a equal volume. Whatever the volume of the substance equal to the volume of the equal volume of the water. So both quantities have the same volume. I'm not asking that both substances have the same mass. No. Same volume does not mean that the substance have the same mass. So mass of substance divided by its volume, further divided by mass of water at 4 degrees Celsius divided by equal volume of the water. So mass of a given substance, so what will be going on, volume cancelled out with the volume, then the mass of the given substance of the given volume and the mass of the equal volume of the water at 4 degrees Celsius. So this is called the relative density in term of mass and in term of this here density, that is density of substance over density of water at 4 degrees Celsius. So here there is a table 2.2. So here there are some substances and their relative density. Look at the gold. Gold has maximum relative density 19.3. It has no units. So mercury in the liquid state, it is matter, but is it in liquid state? In liquid state, mercury has a maximum density 13.6. Now look at the lead, silver, copper, iron, all having, look at that, this third table. This is in the decreasing form: aluminium, glycerin, ice, kerosene, cork, and the seawater. They are giving the different type of the relative densities. So again, look at this example. As I told you, unit of relative density, it is a unitless quantity. For example, they are giving the density of the copper 8,900 kg per meter cube, density of water at 4 degrees Celsius of same volume 1000 kg per meter cube. So what is the relative density of the copper? Density of copper divided by density of water at 4 degrees Celsius. So put these values, kilogram per meter cube, cancel with the kilogram per meter cube. So we will get 8.9. So relative density of copper is 8.9. So it is a unitless quantity. Thank you.